Well, we're going to get started. Welcome to Game Design with Snap. My name is Servane Demol, and I am in California, in Northern California, in the Bay Area. I used to be a computer science engineer. I worked in the Bay Area for more than 10 years in tech companies. And then I just decided to go more towards education. I created a nonprofit called Code for Fun, and our goal is to expose as many kids as possible to computer science before they go to college. So we offer a lot of programs, but we also put a lot of our time into creating curricula that we can share with teachers, and we do teachers training. So this is basically a presentation to, if I can go to the next slide. Yeah. So basically the objective of today is to introduce you and especially instructors to a curricula that you can use in middle school, and in order to introduce students to programming. So during this session, it seems that we have enough, we have a little bit of attendees coming in still. So Smita, I think, Samita, what we'll do is that we'll take questions in the chat window, and Samita is our volunteer. She's in London, and she will keep track of the questions. And when I stop for questions, she can let me know what questions we had in the chat window, so I can focus on the presentation. All right. So how can you access the material? And this material is, can be used by teachers, can be used for clubs, can be used by students who want to learn on their own. So basically you go to codeforfun.com, and I would like you to do it now to make sure that there's no connection and no permission error, and so that you can have access to the website. So I put the website, the URL in the chat window. Okay, with some typos.
Works for me.
Yes?
Yeah.
Once you get to this website, you will see in the menu something that says for teachers. Scroll down to lesson plan 6-8. So this is in US, 6-8 grades are basically middle school. Once you get there, you'll see something called game design and a button that says lesson plans and slide support. So I'll break out to where you should be landing. You should be landing into a public folder that looks like this. Give me a thumbs up if you are able to see this public folder. Thank you, Hélène. Thank you, Irene. Okay, Joe is in. So again, this is the URL to get directly to the page. And then once you are, so I put it in the chat window. Once you are in there, you have all of this. So I'm just going to describe a little bit to you what this category is, and then we'll go into the details about the content. So you have a teacher's manual that will describe you every session. This is a 10 session of 55 minutes lesson plan. So you have the teacher manual. You have a student book that you may want to use for your students or not. And then you have also presentation that you can use inside the classroom. I have new people coming in. Welcome. So basically, in the chat window, you should see a link of where to find the material for this class. the lessons, so the each of these slide decks have also inside some videos. And so if you just want to watch the videos, there's a video folder, a directory, and all of those videos are in MP4, but the videos are also being posted onto our YouTube channel. So it's a little bit more convenient sometimes to watch it from YouTube. So this is just to give you an overview of the content of what we have: slides for the classroom, your teacher manual to get prepared, and some videos to either train you as a teacher or use during the classroom in front of your students. All right, so I'll go back to my presentation. Do we have any people who have difficulties accessing the material? Okay. So basically, what is the so we went through this. What is a lesson plan? So basically, this is really an introduction to Snap, and it's an introduction to programming for students who have very little to no programming experience. The first lesson, the first session is basically an introduction to Snap. So we get the students to create their account, and then we create a small game, which is called Get the Cat. And I'll show you in a bit after that what this game looks like. Get the cat, just have an object moving and you are trying to click on it to get points. So something rather simple. We also want them to explore other games that are over there on Snaps to get some inspiration and to get used to the blocks and to the environment. The second and third sessions are basically about creating a game, which is a maze. So you have a little character that has to navigate through the maze and get to the end point. And we're introducing the levels. So how, once you finish one maze, another one comes up and you could change your character at this point. So how do you get events getting triggered to basically manage your backdrops and your characters. So this is the third one is flying robots. It is 3 sessions, and basically it's flying robots trying to get through different pipes. And we're trying to teach also gravity. It's a little bit more complex. So I will really want to encourage you to follow how the lessons are being unfolded in the manual, and not just give the code to the students and without any explanation. You want them to build the code as we go by asking them questions, and the slide decks helps to do that. Finally, the fourth sessions is basically so the 4 last sessions, they are basically about them creating, so having your students creating a game on their own. And we want them to use a design thinking process, which is basically a certain process that we have documented inside the lesson plan. But basically, they're not designing a game for themselves. They're designing a game for somebody else. So they have to go and interview the person in the classroom or a person outside the classroom that they want to create a game for. They have to provide, a summary of what the game features are going to be. So we're following a little bit the design thinking process, which is empathy, prototype, testing, and then implementations, and then it goes on and on like this. During this, another very important point that we have in this lesson plan is that we also want to introduce the students to flowcharts. So in the flying robots lesson, we are asking them to consider the flowchart and draw the flowchart diagram of an algorithm before they continue. It's actually very, very important at that age to be able to talk and explain about an algorithm using flowchart. So we have some examples about flowcharts, and they have to understand what the flowchart is doing, what the program is doing by just looking at the flowchart. And then before I go into the content a little bit more, this curricula is aligned to two different frameworks. One is a CSK12 framework, which is kind of a framework that is across all the United States, and it's also aligned to the California K-12 CS standards. So for the teachers in California, these standards have been defined about 3 years ago. So or 2 years ago, I should say. So we already aligned it to it. Okay, so I wanted to show you some of the games example. So this is the maze that we have that we're creating, that the students will create at the end. So basically, it starts with, an octopus. Just a second. I think this sprite doesn't need to be there. Okay. So let me make this a little bigger so you can see. And we're going to play the game. So I'm on level 1. And basically, we have this little octopus that is being navigated with up and down arrow. If I touch the wall, then I get some health point off. Basically, I can't get, and then I have to go through this door. And then I change, the next level is basically I change my character, change my starting position. I can take a little longer to go and get some bonus point. So I got just 10 points because I got this red ball, and the ball disappeared. So I can't get it another time. And same thing, if I touch the wall that are in a different color this time, then I get some health point off. And at the end, this game over, we have only 3 levels. So this is a rather simple game. It takes about 2 sessions for the students to build it. Obviously, I've tried this in the classroom, and they get very excited, and you can do more and more advanced features if you want to push it over. Ideas like putting traps, making walls disappear, and opening up gates as you catching up points and bonus points. Obviously, creating more than 2 levels, etc., etc. This game is made with several sprites. Basically, the player, the stage has game over and other costumes. So if you look at the background, it has all the different mazes, which are all of the. Every time you have to create a new level, you have to create a new stage. And those are just blocks that are being put together. You have your player. Your player can have 2 different costumes. For the first level, second level, and the door is actually it's actually a sprite, so that you can change the color of the door, but also you can just easily say if you're touching the door, then you're done. And then we have bonus points, so the bonus is also a sprite. Any questions about that? I'm not going to go too much in the details on how to make the game because of we don't have the time, but also it's all explained in the manual that the teacher's manual that we have. Do we have any questions? So the question is, am I using any other functionality of Snap that will not be used in Scratch for this project? For this particular project, I will say no. I think whatever you're doing in this particular project, you could do it in Scratch. This is again, because some of the students might just come to the class in middle school without having done any programming before. And so So we will want to make sure that they're getting used to the environment, the blocks, and kind of the, oh, there is one thing that I'm using. This is the reduction health is actually, so it's a method. And the method, the way to create a method is a little different in Scratch than it is in Snap. So that would be one thing. It's just that if you are a scratcher, a heavy scratcher, you will find that creating blocks in Scratch is a little different in Snap, because now you create a method that can be create accessible by any sprite. Okay. All right. The other project is the robot project. All right. So this one has, it is, the code is much more complex, but again, the lesson plans just show you how to go step by step. So the first thing is we're just focusing on the robot and making it fall. So if you see, if I play my game and I don't touch anything, my robot will fall and will keep on falling. And then we want to use gravity. So how do we simulate gravity? So we go through that. The second, we have the barriers that are going to change colors and keep on moving. We have a fuel tank, because actually you can start flying, but you're burning fuel. So you have a fuel gauge that will show you, the different levels of your fuel as the fuel level goes down. But then if you grab the canister that shows up some of the times, then you can refuel. So let me play the game a little bit so that you can see what it looks like. So if I touch the bar, then I'm not very good at this. It's my game, but I'm not very good. Okay, let me start it again. Okay. Yeah, the boost is too much. I'm boosting it too much. But basically, I'm trying to, it's like the Flappy Bird game. Okay, here you go. Once you get, so you can see I'm burning my fuel and I'm out of fuel. So now I'm falling down. So I didn't get the canister. You can slow down the game to make it less difficult. I should definitely do that because I'm not very good at it. Okay, I wanted to show you what a video looks like. When you're on YouTube, this is our videos, and I'm going to disconnect here the video. And you can decide if you want to use this in your classroom or not.
Hi, in this lesson, we're going to create a robot, and we're going to just trying to make it fall using the forces of gravity to accelerate the movement and the speed as the player falls down. And we're also going, so here's going to look like the robot is basically falling down, and the speed increases as it gets closer to the ground. And then when it touches the edge, then it stops falling. And then we're also going to create a boost that helps the player go back up into the air and fight gravity. So how do we create that? In our program, what you want is a costume of at least one flying robot. So you create a new sprite and create a costume of the object that you want to fly. You can import new images that you have found on the internet by going and using import, and then you can import any graphics that you want. In the scripts, when the green flag is clicked, what you want to do is switch to the right costume. in my case, I wanted to point it in the direction to the right because the graphic that I imported was basically facing the other way. And I had to reduce the size also because the graphic was pretty big. Now, if you want to make an object fall down, we know that we need to make it, we need to have its y value change by a certain number until it touches the edge. So we call v speed the velocity, which is the speed by which the player is going to fall down, and it's negative 0.25. And let's say that we don't change the v speed. So right now we change it by 0. And we go to a certain height, and then we repeat until we touch the edge, change y by v speed. So this is a constant speed. And this is what's going to happen if my robot is falling down at a constant speed. So obviously, this is not what we want if we want to simulate gravity. If we simulate gravity, we want to make sure that the speed is going to increase as we fall down. So what happens is instead of changing the speed by 0, we're actually going to increase it by a certain number that is set by the gravity. So I create another variable and I set it to minus 0.5, and I'm going to say instead of changing the speed by 0, I'm going to change it by gravity. So as I repeat this loop, my velocity is increasing. Well, let's try it out. Well, you see that the speed is increasing. So this is exactly simulating the gravity as we're falling down. So that's what you want to do. Okay, great. Now we want to make sure that we repeat forever the go to a certain position, repeat until you touch the edge, and once you touch the edge, wait a little bit and then fall again. So this is going to basically make my robot keep on falling. And you can see that the gravity is, the v speed is being increased as we go. So maybe what we want to do is that we want to set the v speed back to a certain amount before we make it fall down. Okay, here we go. Now we have a constant falling movement. Well, okay, now we want to add a boost. Well, the same way we created a gravity, we're going to create a boost. And then this is all variables that I have created already. I made them local because for me, the speed, the velocity of the robot and its boost are things that are only for him. If I have two robots, maybe I want to have two different boosts and two different velocity as they are carrying a different weight. So that was something that I chose to do. You can make that global if you want to. I'm going to stop this script. And what do we want to do? Well, as we want to repeat until we're touching the edge, we also want to make sure that if the space key is pressed, then we change the v speed by boost, which is a positive number. So let's see what happens now. Slowing down, I'm hitting the space bar. You can see I'm getting back up. Which is exactly what I wanted to do. I'm going to stop this and show you the code again. That's how you can make a flying robot fall down and simulating the gravity and also setting up a boost.
Okay. Let me get out of that. Question. I just wanted to show you what a video looked like so that you can decide, how you want to use it, if you want to use it in your classroom or just to get trained on how to get prepared for your classroom. So one of the question that I saw in the chat window is, can I reuse this or modify the documentation? So yes, you can reuse it. You can reuse it. If I open the manual, so for those who just came in, how do you access this particular drive? You go on to our Code for Fun website, and you go to For Teachers lesson plan 6.8, and you have the lesson plan from game design. We are curating the internet. When we do that, we do not sell our curriculum for teachers. We do not sell our training for teachers. Everything is for free. So we want to make sure that we respect the sources where we got the ideas from. So if you are using this and you're printing it, make sure that you keep track of the credits that we have put over there, because this is where the different organizations that help us put this curriculum together. So obviously SNAP, but also other things, and you'll so if you can reference us, and you can see we're using Creative Commons by attribution label. So you can definitely use it, print it. You can modify it, but this is a PDF document. So if you want to modify it, you will need to reconvert it first. You can and you can share it with other people. Please share it. And it would be the only thing that if you could do for me, that would be great, is to give us feedback. Like, how did you like it? What was working in your classroom? What didn't work? Because then we can share that with other teachers and make the content richer. So if I wanted to show you a little bit how this manual has been created for the teachers. You have first a section of overview that describe you exactly which lessons. You might want to just do 1 or 2 lessons. You maybe just the maze. You might not want to go to the robots. You might decide that, look, I'm just going to give them a little bit of introduction, and then we'll go directly into the lesson 7, which focuses on creating their own game. Where's the PDF located again? So if you go to our website, yes, thank you. You go to your website and then you click on game design, lesson plan and slide support. You'll get directly into that folder that has the manual for the teachers, a manual for students, all of the slide deck that you can use for your classroom. You can import those slide decks into your own Google Drive and decide to modify it if you want. That's fine. You should not have the permissions to modify these ones. We want to make sure that this stays the way it is. And then you have the bunch of videos that are linked from the slide decks. They are here, and they're also on YouTube, on our YouTube channel. So going back to this, we're describing a little bit what the lessons are. We're giving you a glossary of all the terminology that we are using in this document. And then obviously, what do you need? An internet access, projector, and I like to have a student design journal or reflection book. It's very good when for example, if you are trying to introduce gravity, you might want to make them think about how do you define gravity? Just before you go through the lessons, how do they feel, or what do they know about something? And so to make sure that you capture that, and then after the lesson, okay, what did you learn? What is different now? Do you understand gravity better? And then each lesson is basically about 55 minutes, and you have the resources link. Basically, we give you a guidance about how you should spend your time. Obviously, this is plus and minus, but and then all the links to the videos. I wanted to, we have a little bit of time, so I wanted to actually go through, so everything is, step-by-step instruction. And so this is the but I'm going to focus a little bit more into one item that I pointed out, is that we are using flowchart diagram. We want to teach flowchart diagram to the students while we're doing this, because this is kind of a universal way of talking and explaining algorithm across across engineers. And actually, you know, when I was interviewed in many different companies, and they're asking me an algorithm, usually we will write the flowchart diagram. We will not write code on the whiteboard. We will just put the flowchart diagram of the algorithm for the solution, because then it doesn't matter if it's Python, C++, or whatever, it translates. So we want to show them like how you create a flowchart diagram. They have at the end, you'll see at the end of the section, and they have that in the book also, you will have an appendix that shows you an example of how a flowchart diagram works and how what the convention. So in this one, in this diagram, this program is starts by asking the users for its age, and it stores the value in a variable called age. And then we have a conditional that asks a question, is the age less than 18? If it's true, then we have to grow. Otherwise, if it's false, then we can say you're an adult. Something very simple, but it embeds input. So input has a special shape for a flowchart diagram. It embeds conditional, which is the diamond. And then you have a loop that goes, that keeps on growing. So you have the concept of the loop as well. In this diagram, they have to read it, and they have to realize that this is a rock, paper, scissors kind of flowchart diagram. So this is an exercise, and then you can, once they know the flowchart diagram, you can ask them to continue writing the script in flowchart diagram before they actually put it into Snap. Into Snap. And then lastly, the last sections of the, sorry, I'm scrolling down, but in lesson 7, design your own game, we are using the design thinking process with the students. So it's very important to pause over there and to explain what the design process is. This is not actually a linear process. You just keep going back from define to empathize, from the idea to define. I mean, you can go back and forth, but the point is that you want to know your audience first, so that you can define the solution to you to the problem, or you can define exactly what your audience is looking for. You go through an ideation phase where, you know, a lot of post-its, and you make, you know, you come up with different solutions. You go back to the user, that's called a prototype, with your post-its, and say, I have this idea, I have this idea, what about that? You don't create anything yet. You don't want the students to rush into programming and start programming a full-blown game before they go back to their audience and ask, is it what you were looking for? Because if they have put too much work into it, the students, the original audience, is not going to feel comfortable telling them, well, actually, I didn't, this is not what I was looking for, right? So you want to make sure that you sketch it and you have a raw sketch, and then you can get some feedback. And then so that's the testing phase. And then you go back to, I'm going to define, ideate, prototype, etc. So this lesson explains the steps of the design thinking process. And then after that, it's up to them to basically create their own game. I'm going to open it up for questions. So I'm going to, do we have any questions in the chat room?
So I was just thinking through, because we work with K-12 students through our business, but then I also teach community college students, and I've taught online for years, but now everybody, of course, is teaching online this semester, at least almost everybody. Anyhow, so I always do like a project with face-to-face with Arduinos, just because I teach a one-on-one class, so it's just to give them a taste of programming. And it almost seems like I could use this, at least parts of this anyhow, with the community college students. Is it?
Yeah.
I mean, yeah,
Yeah, it's not
that's not really a
limited.
question. I'm just thinking through.
Yeah, I think this is true. I mean, Professor Garcia actually, introduced Snap. Is still in Berkeley to the 101 students because it takes away all the problem with the syntax, and we
Right,
go straight into the thinking,
right.
which is what block programming is great at, and Snap has really no limit when it comes to programming. Um, and so I think this is a great way to introduce the students. There's always going to be the students who have done a lot of block programming and they
Yeah.
feel like block programming is not real programming, but the complexity of these games hopefully will give them a good sense that you can do a lot with even with block programming. And so getting them into a project where they're like, okay, design whatever you want, and if you are actually an advanced programmer, then I expect you to show me something surprising. Then it can they can really have fun with that. So yeah, I think this is a great idea, at least to give them a good taste of what programming looks like. Because for people
Yeah.
who are starting, sometimes just typing code is really frustrating, and they don't like it, and they don't get an appeal for it. But this is a very different approach to programming, and it gets much more fun in the first, at
I
least in the first
I tell
few.
my students, well, I tell my students this is the gateway drug to higher programming.
Right, right.
Stuff like this.
Thank you for sharing.
So do you think this would be um, so even with our K-12 students right now, and we have a big group of middle schoolers, so this is perfect, but we're doing everything online in the fall. And so
Yes.
we do very constructivist hands-on, like we always bring all the tech and the Arduinos and everything. But we're thinking through like what can we do to keep that same level of interactivity online. So I haven't read through the teacher manual yet. I just downloaded it. But do you envision this being something that would be able to implement in an like we meet
Online,
in Zoom and
yes.
go through stuff?
So I teach online. We have switched our teach online since April. I've not taught this during the summer because, but I think when I'm rethinking about the material that we put out for instructors, is that having a teacher manual is not enough. So we always had the slide deck, and you can see through, because we have other lesson plans, you'll see through all of that. You can explore, and no, I don't want to get too much into it because this is not Snap related, but we have created a full K-12 CS standards for grade 3 to 5, and this is 1 hour per week. So if you want to do 1 hour of computer science per week for your grade 3 to 5, we have all the content. So we have put out all the content last year. So what we have done is a teacher manual and the slide deck. But I think what's the great thing about this one is the videos, because if you want a refresher, as a refresher, or some students missed a class and they need to catch up, then the videos show them the step by step, and hopefully they are good enough to show them, like explain them exactly how the code is being put together step by step, and not just giving them the result code. And then that's a lot of books do that, right? They just give
Right,
you the entire solution at the end, and you just end up copying without
right.
understanding what's going on. So yes, we have to kind of like be a little bit more digital and do a little bit more work when we are putting stuff out. And I think this is why I wanted to present it to this conference, and that this is a good opportunity because I think it will gel well with the online education. Now, please give me feedback and tell me, what else it would be great. Maybe a longer session than just an hour to actually go through the material. I mean, I don't know. That's at this point, this is up to you to let us know what else can we do to make sure that this is used.
So where is that section that you just showed that had the CS? Yeah, this one.
Oh yes, so this one, same thing on our website. You
Oh,
go
okay,
for
okay.
teachers, instead of going to lesson plan 6.8, you go to lesson plan 3.5,
Gotcha.
and you scroll down to the deep dive. And
Okay.
again, if I open it, this is everything that you want for it's all
Wow.
the units, 5 units for each grade. It has books attached to it, so I have actually books printed. And so if you want to give the books to your students, they can get the book, and they can write in it. So you have all of that stuff.
That's
So
fantastic.
yeah, this is the work from last year. Whatever grant money we got, we just put it into this project. So we're pretty happy to have it out. So yes, please share if because now we are going to be using it full blown this year, and we want to make sure that we have enough feedback so we can make it better and better.
So I'm seeing, so I clicked on the grade 3 workbook, and
Yes.
it's about 121 pages.
Mm.
Is that, so in a time frame, let's say an hour a week, is this a full year of stuff, or
Right,
is it a
it's 32
semester?
hours of
Okay.
32 lesson plans. Yeah, 32
Okay.
hours. So you have plenty. I mean, usually
Yeah.
if you don't finish, it's okay. We
No,
just
that's
want to make sure.
fantastic.
Is the game available on the Snap site? Oh, that's a good question. I don't think so, but I could make it available if that's something that you want. I mean, in that case, your students are going to be able to find a solution. So that's a question if. Do you guys want it on the? Do you want me to put it on the Snap site, or the? I think there's a way to share it, right, on Snap, the same way we do it. Oh yes, okay, I'll share it with you guys.
Well, is it something you could put in the Google Drive folder? Like if you don't want the students to get access to the
Oh,
full
okay,
answer, and then you add it to the resource folder for the teachers.
okay, I can do that. I'll put the I'll put it on save it and put it in the Google folder. That's easy enough. XML, right? This can be done right away. As I'm
Through the magic of computer technology.
share the Snap link with us. Yeah, but if I share you that, I need to do something to share it, right?
Yeah, everyone can import it into Snap once they download the XML file.
Okay,
Perfect.
okay.
Perfect. So this is a newbie question because I haven't actually used Snap. We've used Scratch and lots of other things. Is Snap only accessible online, or is there a downloadable version to use locally?
That's a good question. I only know about the version online.
Okay.
I don't know if other people have used.
Download it.
You can download it, and that's
Yeah.
Andreas. Okay.
Yes, you can download it and use it offline.
Perfect. Because we work with rural students sometimes in places that don't really have great internet connections.
Okay.
And so that would be great. Perfect. So could they access the game if they downloaded the XML file? So someone said they can't access the game without the Snap site.
They should be able to. If they download the XML file, they can import it into Snap, I believe, or drag it in. I'm not 100% sure about the offline version, but they should be able to as long as they have both downloaded.
We'll have to test that out. Even though we're in Southern California and everybody thinks we're all connected here, we actually live in a pretty rural part of that in the high desert. And we have people that are still on almost dial-up type connections.
We have Joe said that he has tried importing in XML into an offline version.
Okay, good.
So,
Perfect.
so that would be. So what I could do also, that I could download the other game, also the maze game. It's not very complicated, but I'll do that. I'll just add it to make sure. So how can you give us contact? So if you have, if you're using this curricula during the year, and you would like to give us some feedback, good, bad, ugly, give it all, please. You have on our website, we have a contact us. And that's one way of just creating a message and just sending us a little message. I want to also give you my personal email address so that you can always contact me. I'm going to put it in the chat. And if you're looking for anything for your school, training for teachers, like how can I help, how can I help training more instructors like you and give you more resources? If you're looking for something, please let me know. We would love to be at service to the teachers and students. If you're a student and you have a question about anything, just contact us. Okay. So to summarize, to make sure that everybody has the link for the accessing the material for the class, I'm putting it again inside the chat window. Once you get to this page, you can click on lesson plans and slide support, and then you have access to the material to teach 10 hours of computer science. Ideally, middle school can be done, later on if you want. It's not only for middle schoolers. You're welcome. And I hope that some of you can use it and that you are successful in your classroom and with it. And we would love to hear about that, about your experience.
No, this is fantastic. Thank you so much. About half the students that come into my CIS 101 class want to be game designers when they grow up. So this might be a fun place to start.
Yes, game is always an easier topic because they like to play games, but here you're telling them, no, you're going to make your own game, and then they play each other's games. And so it's a topic that actually goes well between genders. So so it's usually, something that we like to introduce. Thank you for coming into this conference and for joining this session. I'm very happy to see so many people. For us, it was 8 o'clock in California, so I was skeptical on how many people we were going to get, but I'm so happy to see so many of you. So thanks a lot.
So Demol,
it was a little early, but it was worth it.
I was going to ask about how to get the games converted to physical gadgets, how people could use it. So I know it's you can only play it from the XML version on Google, but is there a way it can be converted? I want to get some hints from you.
So I'm not sure I understood exactly what your question is about. You're trying to get the code?
If when you code the games in the Snap platform, it's always in the XML version. So for any person to play it, he needs to access the Snap platform to play it. But if you want to play it like a console game, you want to convert what you've done to be playable, maybe like an app on phone or even a gadget. Yes, that's what I'm asking. How is it possible and how can it be done? Thank you.
Do anybody have any experience with that? I will throw it back to the audience. So the question is that what if we want to export this game and let other people play it on the phone?
Yes, if they export and share the link, you can open in a small device the game. If you share the game, that is something that you can show to the parents, let's say in the phone, how the game works, but it's not itself. It will run through Snap in like just the screen, the small screen without the code. You can see just the screen.
Yes. You will only see the this screen over there, right? But how do you export?
You need to get permission to share the link. When you share the link, if you email the link to someone else, they can open and see it in their phones or any computer device.
The link that I have here is very generic.
Share, right at the bottom. It says share. Okay, exactly. Go to my file and then save as. Save
Oh,
as.
share. Okay.
You see at the bottom, it says share, and then you need to rename it. And then that link is the one that you're gonna share. Then you need to save it again, okay? And it will look darker in color. That means it will be bold. The name of the project will be bold. That means that that project is shared.
Okay.
Now you need to save. You can share in the cloud. Yeah, you share, and then you save. When you open the project, it will look darker. It will be bold. The name of the library, it will be bold. That means that it's shared. Where is it?
Yeah, it's not bolded, but it says.
It says share. You need to share that.
Okay, now it's bold.
Share. Make sure that it's shared.
Okay, now it's bold, and now I have a URL.
Now it's bold. And then that link on the top.
Yeah.
And then you share that.
I see. Okay. Excellent.
So you can use any phone or any computer device. You don't need to be enrolled in Snap. So it will open.
I see. Okay, that's awesome. Thank you very much.
That's the last phase of the question is, you don't want to play it in an online platform. If you want to convert it to an app or a gadget people can hold and play it offline, how can that be done with this XML?
That I'm not sure, because XML file is really just a text file, and there's no programming in there. It's not an executable.
No, in that case, they need to download the offline version in the computer. It's just the computer. They need to have that already upload in the computer, the decoder.
Okay, that's great. That's great.
Mm-hmm.
All right. Well, thank you very much, guys, for attending. I want to really express my gratitude for having you today, and I hope you enjoyed this presentation. And please don't hesitate to contact us if you need to. Yeah, I think we are going to be about up to the hour. So thank you and have a great day.
Thank you very much. This
You're
was
welcome.
fantastic. Even if it's 8 in the morning, it was fantastic.